Figure 11.15 and 11.16, ButtonFrame.java and ButtonTest.java. In this example, we're going to revisit some of the same event handling concepts that we just presented to you, and also in the process introduce the new JButton class, which will be used to create so-called command buttons, and also the interface called icon and the class called ImageIcon, which implements the icon interface. It turns out that many of the Swing GUI components are capable of displaying icons, and in the case of a JButton, you can use those icons to create a rollover effect as well, which we'll show you in just a moment. The other things that we're going to be looking at in this example include the nested class concept once again, and also the ability to load a resource such as an image from the same location that your program's classes were loaded from. And then finally, going back to the concept of nested classes, how is it that a nested class can refer to the outer class's this reference, which can be useful, as we will see, to show a dialog centered on the main application window and potentially for other things as well. So before we look at the code, let's go ahead and run this program so we can show you the basic application, which is just this small window. These two buttons are laid out in a flow layout, and you can see as I hover over and in and out of the button that there's a little bit of a visual effect there. And in the case of the fancy button, as I move in and out of the buttons area, you can not only see the visual effect of the border, but also the fact that the image is changing. In particular, I have a white backgrounded image and a yellow backgrounded image, and it's just switching in between those. All right, so let's go ahead. Oh, one other thing, excuse me. When you click each of the buttons, it's going to display a dialog saying which button you pressed, and it'll show you the text on the button in each case. And then finally, if you stretch this window, we can really emphasize what's going on with the dialog box and the fact that it's being centered over the window. In fact, let me move it up to the left corner here to overemphasize it, and you can see that the dialog is centered in the main application window. Also, you'll notice that I can't click in the main application window because this is what we call a modal dialog. Until I dismiss this dialog, I can't get back and interact with my other buttons. Okay, let's take a look at the application now. Our class called ButtonFrame extends JFrame as we did in our prior example, and we've declared two private JButton references, plain JButton and fancy JButton, that we will initialize in our ButtonFrame constructor. Inside the constructor, we use super to specify the title bar string for our subclass of JFrame. And once again, we've set the layout to a new flow layout just for simplicity in this example. Now, as with many of the GUI classes, the JButton class has a few different constructors. This particular one takes a string, which represents the text that will be placed on the button. And here we're creating the new JButton, assigning it to plain JButton, and then attaching that JButton to the user interface. At lines 26 and 27, we declare two icon variables, bug1 and bug2, and we initialize each with a new image icon. Image icon is a class that implements the icon interface, and image icon is capable of loading up an image from a variety of different sources, one of which would be a URL that specifies where the source is located, either on your local file system or potentially across the web using an actual URL of a web destination. Now, in the body, or in the call to the constructor rather here, we have an interesting expression in which we obtain this class's class definition, this class being the class ButtonFrame that we're defining. Specifically, we obtain the class definition for the current object of class ButtonFrame that we're manipulating at runtime. That comes back to us as an object of the class called class, which has a method called getResource, which is quite interesting. It turns out that every class, when it's loaded into memory, has an associated class loader that loads the class into memory. The class loader knows where that class came from in the first place, and it's not uncommon to store resources that are associated with an application in the same folder with the application itself. So what we're saying is use the class loader's getResource capability to create a URL that represents where this bug1.gif file is located, Then I'll take the URL that's returned and use it as the argument to the image icon constructor. So if the class got loaded from the local file system, I will get back a local file system URL and then use that to load the image. If the class for some reason was loaded across a network, I will get an appropriate network-based URL, perhaps a website or FTP site, and that in turn will be used to load up the image. At line 28, we create a new JButton with the text fancy button on the button, and also the image bug1, and as you saw in the running program, the image was automatically placed to the left of the text, but that is a configurable option. And then at line 29, we tell the fancy button to set its rollover icon to bug2, and by doing that, we enable the capability of showing a different image each time the mouse moves into or out of the corresponding button. And it will basically switch back and forth between bug2 and bug1 automatically for me. We then attach the fancy JButton to the user interface, and as we did in our last program, we want to specify that we'd like to handle events when the user clicks the fancy button or the plain JButton as well. So we've created an object of our own class called ButtonHandler. It's a private nested class down here that we're going to look at in just a moment. Once we create the object, we pass that object to the addActionListener method for each of the two different buttons. Now, as we had in the last program, text fields have action listeners to respond when the user presses enter in a text field. Buttons have action listeners to respond when the user presses the button. That could occur via a mouse click. If a particular button has the focus, it's the currently active button, you can press the space bar to press the button. Or if a user has a disability and is interacting with their computer, perhaps with their voice, they might read the actual label on the button, and then the assistive technologies that they're using would in turn cause the button press event to occur and give us an action event that we can respond to in our program. Now, our ButtonHandler class, in order for an object of this class to be used with addActionListener, it must implement the ActionListener interface. And by the way, I should point out, notice that the name of the interface is in the addActionListener method name. So right in the method name, you know immediately what interface you need to implement for the argument that's going to be passed to that method. So because it implements ActionListener, once again, we have to define the actionPerformed method that receives an action event parameter. And within the body of this method, what we're saying is that once the user presses either one of these two buttons, we're going to call jOptionPane.showMessageDialog, and we're going to give it two arguments. The first argument is going to help us determine where the dialog gets placed, and the second argument is going to be a string that represents what should be displayed as the message in the message dialog. Now, the message in this case will indicate you pressed and a string, and the string that we'll display is the result of event.getAction command, which in the case of a JButton is going to give us back the text on the JButton. So we'll say you pressed plain JButton or you pressed fancy JButton. Now, this syntax on line 44 is quite interesting. ButtonFrame.this. Normally, the first argument to show message dialog points to the parent window. In fact, if we go take a look at the online documentation and look at the JOptionPane dialog class, here's the JOptionPane dialog class, and I'm going to go to the showMessageDialog method in this class. So there's quite a number of methods, as you can see here. The particular version we're using right here says that the first argument has to be a component, and the second argument is the object that we want to display as the message. So some sort of a component, some sort of a GUI component has to be the parent of our dialog if we want to center the dialog over that parent component. Well, if we go back over here, let's assume for a moment that we just said this. Well, this is the current object of class ButtonHandler, and this is not a component. This is a ButtonHandler. It is also an object because we implicitly extend object, and it's also an action listener, but it's not a component. We don't want this class's object to be the one that is the parent component of the dialog box. We want the actual button frame to be the parent of the dialog box. Well, when you're using a nested class, you can access the outer class's this reference by manipulating it through the class name itself. It looks kind of like a static member reference, but in fact it's just a special syntax for accessing the outer class's this reference. So by saying ButtonFrame.this, we're saying that whatever the current object is of our ButtonFrame class, its this reference should be used to specify the parent component for the dialog box, and in turn the dialog will then be centered over the ButtonFrame window. So you can see here a couple of new features that we haven't discussed before. One other thing I want to do is just take a quick look at the JButton class in the online documentation. So if we again go back to our javax.swing package, here's our JButton class, and notice first of all the hierarchy of all the types that make up all of the functionality of a JButton. In particular, a lot of the JButton functionality comes from abstract button, which is a superclass to a variety of button types in the javax.swing package. Now, when I showed you the event handling concepts in the context of JTextField, I went to the method listing to show you various add something listener methods. And as you can see here in the class called JButton, there are no such methods. It turns out that the registration methods for event listeners come from the abstract button class in this case. And I'm going to go to that class and show you its methods, where you can now see add action listener, add change listener, and add item listener. And it turns out that there's various different types of buttons, and the concept of an action listener, a change listener, or an item listener is something that you would choose based not only on the type of GUI component you're using, the type of button you're using, but also based on the type of information you wish to receive as the event object into your event listening method. If all you really care about is the fact that a button got pressed or interacted with, then you can simply use an action listener. If you need to know that a button's state has changed, you might add a change listener. If you need to know that a particular item was selected from a particular type of button, such as a combo box, which is the drop-down list button, you might use an item listener in that case. And you'll get hints about this stuff from the descriptions of each of the classes as you look at them in the online API documentation. So technically I can respond to any one of these three types of events, action events, change events, or item events using an action listener, a change listener, or an item listener respectively on a JButton. However, the vast majority of event handling for JButtons is performed via the add action listener interface, and again, all we need to pass to that function or that method is an object that implements that interface. Any object that implements action listener can technically be used to respond to a JButton's action event.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.